Hey guys, so some of you may be familiar with this old game that I was working on a while back and may continue working on sometime in the future. But for now, I just wanted to create a little tutorial series to teach you guys how to create the sort of setup for your own game. So let's get started. Okay, so in this first part of the tutorial series, we're just going to be setting up our character controller. So there will just be this little cube, and he's going to be able to jump around and detect collisions above and below him with raycasting like this. And then after we finish setting this guy up, probably at the end of part 2, then we are going to move on to the fun stuff, all the graphics and cool effects and whatnot. So yeah, let's get started with this. Okay, so starting off in a new project here, let's just set up a basic scene. So I'm going to change this color to a light gray just because I prefer it. And let's change this to an orthographic camera. So it's going to be two-dimensional with a size of 5. So now we can just add in a cube. And let's just put this at 0, 0, and 0. And for the time being, this is going to be our player. And if we just duplicate this, and we can call this the ground, and we'll just move this down and scale it out like this. Okay, let's also create a new folder, and we can call this materials, and just Command D to duplicate that, and this will be our scripts folder. So in the materials, let's just make two materials, one for the player and another for the ground, and we'll just give this a greenish color, and the player, we can make the player blue. Okay, and we just need a basic lighting setup and then we're done. So let's make a directional light, and we can give this a yellowish tint, just something like that. And we'll duplicate this and give this one a bluish tint, and just change this rotation a bit. So let's put this one like that, and let's just create an empty game object, and I'm just going to call this lighting, and put these two lights in there. Okay, so now we can just see what's going on a little bit better. So now with that set up, let's go into our scripts, and we're going to create two scripts. The first one is going to be called something like player controller or player input. So that's obviously just going to manage all the input and stuff for the player. And then the other one is going to be player physics. So this script will handle all the collisions. You can just go ahead and open this up. Okay, now in the player controller, we're just going to set up a couple of variables which are going to control the way the player handles. So just add in a comment there, player handling. And these will be things like speed and acceleration. Okay, we'll add in a couple more later, but that's it for now. And for the movement, we're also going to want to have a private float, which is going to be the player's current speed. We want to be able to keep track of that, and also the target speed. Okay, so we'll always be incrementing towards the target speed, and okay, that should be everything we need for the moment. Let's start setting this up. So in the update method, we're just going to say that the target speed is equal to input.getAccessRaw. And by the way, I just want to, because there's quite a lot to cover here, so I can't explain every single thing. If there's something that I don't explain, you can just select the thing that you don't understand and press Command and apostrophe, just like this, and it will open up the API, and it will tell you all about it and what it does. So that can be quite helpful. It's just over here, API reference. So Yeah. And this is going to be on the horizontal axis. And we're going to multiply this by the player's speed. And now we're going to want to increment the current speed of the player towards this target speed. Okay, so we're actually going to create our own method to do this. And I'm just going to copy it over from another file because it's quite a lot to type out. Just like this. And I'm going to go through and explain this quickly. So the method is called increment towards, and it's going to take in a float n, which is going to be your current speed, the target, which will be this variable over here, and the speed, which is actually that's a little bit misleading. Let me rather rename this to something like a, okay, for acceleration. So this is how fast it's going to be incrementing. So here basically what it's saying is if the current speed is already equal to the target, then we can just return the current speed because that's all good. Otherwise, we first want to see in which direction must the current speed be incremented to get to the target. So must it be in the negative or positive direction? That's what this mathf.sign is doing. And then we're incrementing the current speed by the acceleration times by the direction. And then we have this confusing statement, which is basically just saying, this is, whenever you see this question mark and then this colon, it's basically a shorthand if statement. So this is the if, well, this is the condition here. This question mark is inside of the if, and after the colon is the else. So we're returning if the direction is still the same. So in other words, the current speed hasn't passed the target once we incremented it, then return the current speed. Otherwise, if it has passed the target, so we've incremented too far, then just return the target. So that's what this is doing. So hopefully that makes sense. So now we can just say current speed is equal to increment towards, and now we're just going to pass everything that's needed into here, which is the current speed, the target speed, and acceleration. Okay, so we can say it's just equal to that, because as you can see, this is returning a floating point number, a float, so that's what these return statements are doing. So current speed is being equal to whatever's being returned here. So now, what we're going to do is we're going to make a vector 3. Actually, we're going to make a vector 2 because we don't need the z direction since it's 2D. So we have a private vector 2, and this is just going to be called amount to move. And let's actually give these some values. Let's say the speed is 8 and the acceleration is 12. Can mess around with those a bit. And now we're also going to want a reference to this player physics script. So we can say private player physics, and we can just call it player physics. And now in the start method, we're just going to set that equal to get component player physics. And now because this script is always going to be needing this other script, this player physics script, to work, we're just going to have a require component statement here, and we just need to say that it's of the type of player physics. And you'll see exactly what this does in a moment. Is if I go into Unity now and I go into our player and just drag in this player controller, because it requires this player physics, it added it automatically. And if I tried to remove this component, it would say it can't because the player controller script depends on it. So that's just a nice thing to have. Let me just save my scene. I'll call it scene. And now what we're going to do is we're going to get into the player physics, and we are going to make a new method, the public void called move, and it's going to take in a vector 2 move amount. So basically what this method is going to do is it's going to take in the move amount with all the current speed and stuff that we pass in from this player controller, and it's going to constrain it to collisions and stuff. So we're going to worry about the collisions at a later stage. For now, let's just say transform.translate by move amount. And let's just get this working here. We can say move amount. Oh, sorry, I said amount to move. Okay, just getting mixed up with my names. Amount to move is equal to a new vector 2. And on the sideways direction, the x-axis, we want to pass in the current speed, and we'll worry about the y later. Okay, and now we can just say player physics dot move and pass in amount to move, and we actually want to multiply this by time.delta time. Okay, let's see if this is working. If we just press play, okay, we can move left and right. Great. So the next step is to stop it from floating and get some gravity and ground detection going. So we're going to go into the player controller, and let's just create a float here for our amount of gravity, and we can just set something 20. And here, let's say that the amount to move dot y is having gravity applied to it every frame. So we're subtracting gravity, and we want to multiply this by time.delta time. And we don't actually want it to be reset to 0 each time. We want it to be cumulative. So let's rather say amount to move dot x is equal to current speed. Okay, so that won't reset the y. Alright, let's just make sure that that's working as expected. If we just press play, you can see it's dropping down nicely there. Okay, so now we need to do some detection to stop it from falling through the ground. So this is going to be handled by our player physics. So what we want to do here is, first off, let's create a float and call this delta y, and we can just set this to move amount.y. Alright, and we are going to want to know where the collider of the player is at all times. So let's just let's create a private box collider, and we can just call this collider. And we want some variables for this as well, say a private vector 3 for its size, and another one for its center, or its position. And now in the start function, which I deleted, so we're going to have to create that again. We'll just say that the collider is equal to get component box collider. And then the size will now be equal to the collider.size, and same story with the center is equal to collider.center. And we're actually going to be doing a lot of calculations with these two variables, so let's just rename these to S and C respectively, just to make it a little easier to type out. And that should be good. Let's also create a vector 3 here. Actually, let's just make it a vector 2 for the player's position at all times. So we can just call that P is equal to transform.position. Okay. And it would actually be good practice in this player physics class just to have this require component thing for the box collider, since here we've got a thing that depends on the box collider. Yeah, that's looking good. So now we're going to do some ray casting downwards to check if there's any ground below us, and then we must not move downwards anymore. So the way that I want to do this is I want to cast 3 rays down. So from the bottom of this collider, I want to have one from the leftmost side, one from the center, and one from the rightmost side going down. So we're going to have a for loop that goes 3 times. So for I equals 0, I less than 3, and I incrementing each time. And in here we want to have 2 floats for a x and a y position of the raycast, and the x is going to it's going to look something like this. We're going to have, actually, let me just copy this all from the file that I've already set up, so I don't have to type it again. So let me just walk you through this. So we start at the player's current x position, and we add center.x. So in this case, center.x is 0, but say we wanted the collider slightly offset from the player for whatever reason. Say if the animation for rolling was slightly forwards, then we might want to offset this when the rolling animation occurs. So that's why that's happening. And we're minusing size.x over 2. Okay, so that's just going all the way to the leftmost side. And now on each iteration, we're adding onto it size.x over 2 multiplied by I. So that will take it from first I is equal to 0, so this won't do anything, so it'll be on the leftmost side, and then it'll be equal to 1, so we'll be adding half, so it'll be in the center, and then at the end we'll be multiplying by 2, and it'll be on the right. And then for y, these calculations, pretty simple, just putting it at the bottom of the collider. And here I'm multiplying by direction, so I'm going to have to put that in as well, because I just copied this from the other code. Direction is just equal to the sign of delta y, so this is going to double as both looking below the character and above the character. So that's why we want to know in which direction he's traveling, because obviously if it's traveling upwards, we don't need to check if he's going to crash into the ground. We just need to be looking above him. So now we're going to set our ray, which we haven't actually defined yet, so let's do that. We'll say ray, that's enough. Raycast hit, just set those up there. And here we'll say ray is equal to a new ray, and the origin is going to be a new vector 2, and we've just set up the origin, so x and y. And the direction is going to be vector 3 dot down, and we're going to multiply this by direction so that it will go up if the direction is negative. I believe that's how it's going to work. Actually, let's do it like this rather. Let's create a new vector 2, x, and for the y we'll just have direction. Okay, then I don't have to think about whether that's going to work or not. Alright, and now here we can say if physics.raycast, and we're going to pass out the ray, and we're going to say out hit, which hit is just going to bring back all the information about whichever collider the ray hit. And then we're also going to want a distance, which is just going to be delta y. And we'll set up a layer mask in a moment, so we'll just call this collision mask. Okay, and this actually has to be the absolute value of delta y, which just means it's always positive, because the direction is defined by this direction we've set up here, not by the length of the ray. So let's set up this collision mask. So we'll say public layer mask collision mask, and this way we can just define what we want the character to collide with and what not quite easily. Okay, and here we're going to want to get a distance. And again, let me just copy this in. This is the distance between the player's position and the ground. And now what we're going to do is we're going to set up another variable, and we can just call this skin. Which seems like a bit of a weird name, but kind of makes sense. Call it 0.005. Value like that should be good. Basically what this is, this needs to be a float, and that's good. So we always want there to be a tiny bit of space between the ground and the player's collider. Otherwise, if it's sitting flush on the ground, then the raycast could potentially go through the ground, and it wouldn't even detect the ground at all. So we always need a tiny bit of space between it, so that it will actually pick it up. So I'm just going to copy a whole bunch of stuff here, just like that. So here we're saying if the distance between the player and the ground is greater than the skin variable we've set up, then its change in position is going to be the distance, or rather the negative distance because it's going downwards, plus the skin. So that's just making sure that there's a little bit of space between them. Otherwise, if it's already within a skin's width of the ground, then we don't want it to move at all. And in that case, we want to be able to say that it's grounded. So we're going to create a public bool called grounded. And let's just hide this in the inspector because we don't want to see that. And it needs to be public because this player controller here is going to want to know when the player is actually on the ground, because, for example, you might want certain actions to only be available when they're on the ground. So here we can just say grounded equals true. Okay, and we can also break, which just means that if the raycast did hit the ground, then we don't need to test any more because we already know that it's hitting the ground, so it would be useless doing it another time or another 2 times. Okay, so now we just need to, instead of translating by move amount, we want to take our alterations into consideration. So we're going to create a new vector 2, and for the x, we're going to just, because we haven't done the x collisions yet, so we'll just say, let's just put this in quickly. We'll say delta x equals move amount dot x, and here we can just have delta x and delta y. Okay, so you can see this delta y variable is what we've been modifying, so that will be the modified thing. And vector 2, we can just call this final transform equal to new vector 2, and we're going to be translating by this final transform. Okay, now what are the chances that that is all gone flawlessly? Let's go to Unity and see. Do I have an error? No, I don't. Now, of course, this is not going to be working just yet, is it? Collision mask, we want to set up a new layer, which is going to be called collisions. So, I spelled that wrong. Collisions. Typing's a bit off today. We want everything that the player is going to collide with to have this collisions layer applied to it. And now on the player, we're just going to select this layer mask and we're going to choose collisions. Okay, let's see if this works. Yup, it seems to. So we were just to take this and put it up here. Actually, let's make it even higher. See, would it fall down? And yep, it hits the ground. That's perfect. And just to test that things are really working how we want them to, let's have a debug.drawRay. Okay, and the ray we're going to be drawing is the one we've created, so we'll say ray dot direction. Oh, wait, first we want its origin. Ray dot origin, and then ray dot direction. Okay, and now we should have this ray being drawn in. Okay, it looked like it might have been a little far apart there. Yeah. What is the reason for this? Did I say less than or equal to 3? Yes, I did. That was silly. Just less than 3. Okay. Now, there should only be 3 little lines. Yep, that is perfect. Okay, so the last thing we want to do before I wrap up this first part is allow for some jumping to happen. So let's open up the player controller, and in here, let's see, how do we want to do this? Let's say if player physics.grounded, so for the time being we're only going to make the player able to jump once they're touching the ground. We'll add in double jumping later if we want that. So if the player's on the ground, then what do we want to do? We want to jump. So we'll say if input dot get button down jump, and that's automatically set to the spacebar, so we don't have to set that up. And then we can say amount to move dot y is equal to jump height, and jump height is another player handling variable we're going to set up. Public float jump jump height, and just set that to 12. I don't really know. I noticed the controls were a little bit slidey, so I'm going to change the acceleration all the way up to 30. And also, when the player is on the ground, we don't actually want the gravity to keep building up, because then when we try jump, all this gravity will have built up and we won't jump very high. So we want the gravity to actually reset when you're touching the ground. So we'll say amount to move dot y equals 0, and this is whenever you're on the ground. So now let's see if this is working. Okay, so we're going to fall down. Okay, it's working, but very, very weirdly. So let's see what I've done wrong. Okay, it just took me a little bit of rooting around to find out what I'd done wrong, and it was just that we set grounded to true here, so it was on the ground, and then after it had been on the ground, we were never saying that it actually ever left the ground. We're never setting this to false. So over here, the gravity was always being reset, so it just froze in the air like you saw. So what we want is just at the beginning here, we can just always say grounded is false. Okay, so we can always just assume that the player is not on the ground, because every frame we're checking if they are on the ground, they'll be set back to true if they indeed are. So now I believe this should work, and it does. That works perfectly. Okay, so let's make this slightly more interesting. Let's duplicate this and just give the player something to jump around on. And you can see it's also doing the collisions above it because of that direction thing we added in. Yeah, so you can see how it's working there with the rays. And what I mentioned before about the slidey controls, I forgot, of course, that because these are public, then if you change them in the code, they're not actually going to change because they're being controlled over here. So that's the one disadvantage to public variables, I guess. So now, well, that resets, of course. 30. Okay, now it should feel a little bit better, which it does. So that's it for part one. In part two, we're going to be looking at support for moving platforms and a bunch of other things that I'm not entirely sure of yet. If you have any questions, please feel free to leave a comment and I'll help you out as soon as I can. And yeah, that's everything. Cheers.